Hello everyone. In this lecture we are going to discuss about the total duration of a project, how to find it, and we'll also discuss the method which is called critical path method. Now let's take an example here where these are some activities and their durations are also given in days or weeks. Let's consider them in days. In that case, so we can write on the side of each activity name the respective durations. A takes 2 days, B takes 4 days, C takes again 3 days, and D takes 5 days, and E takes 4 days. So now if we want to find out the total duration of the project, that means when we reach this last node which represents the completion of activity E, then we'll have to look at two paths, that is path AC and path BD. Now if you consider path AC, A takes only 2 days and C takes 3 days, that is total of 5 days. That means after 5 days we should be able to start the activity E, but E also depends on activity D, which itself takes 5 days, and also it is dependent on activity B, which again takes 4 more days. Therefore we cannot start this activity E on the 5th day, and we'll have to wait for this path to be completed, that means activity B and D. Now activity B and D will take a total of, since this is 4 days and this is 5 days, a total of 9 days, and therefore E can be started only after the 9th day, and after 9th day E itself will take 4 more days, and therefore the total duration will be 9 plus 4, which is 13 days. Now here we can see that the different activities can be started and completed on different days. So activity A can start on day number 0, and it can be completed on day number 2. So after it is completed, we can start activity C, and if activity C is started right after completion of activity A, that means after the second day, then it will take total 5 days, 2 plus 3, so it will be completed on the 5th day. Now if we consider activity B, it can also start on day 0, but it will take 4 days to complete, and therefore on the 4th day it will be completed and activity D can start, and D will take 5 more days and will be completed on the 9th day. And therefore here on this column, which is common to both C and D, therefore if we want to write when this event represented by the node 4 will occur, that means when both activities C and D will be completed, and that will be the 9th day and not the 5th day, because on 5th day only A and C will complete but not B and D, and therefore this node number 4, which as you can see from the network diagram, 2 arrows, this one and this one, are meeting at this node. That means it has to represent completion of both activities C and D, and if it has to represent the completion of both the activities, then it will be only on the 9th day. So after 9th day we can start activity E. Now here we can say that activity A can be started at the earliest on day number 0. So that is called the earliest start time. Earliest start time is when an activity can be started given all the predecessor activities are completed. So for activity A, there was no predecessor activity. Similarly for B also. So for both of them, this day 0 is the earliest start time. Then for activity C, the earliest start time is after the second day. That means on the second day, its predecessor, which is activity A, is completed. So its earliest start time is day 2 or after day 2. Then for activity D, which can start only after completion of B, which itself has taken already 4 days. That means at the earliest we can start D after the 4th day. That's why this represents the earliest start time of activity D. And for activity E, you can see here the earliest start time can be after the 9th day or the 9th day, because its predecessor activities are C and D, and only after the 9th day both C and D are completed, and therefore the day 9 is called the earliest start time of activity E. Then earliest finish time is basically the earliest start time plus the duration of the activity. That means in this case, this day 2 is the earliest finish time of activity A, and it is the earliest start time for activity C. Similarly, for activity C, the earliest finish time will be 2 plus 3, that is 5 days, or the 5th day. But for activity D, the earliest finish time will be 4 plus 5 day, that is the 9th day. And similarly for activity E, it will start on the 9th day, it will take 4 more days, so the 13th day will be the earliest finish time. Now let's come to the latest start time. Latest start time is the latest time when an activity can be started without affecting the total project duration. Now what does it mean is that here in this example we have seen that this path A and C, it has some room for delayed start. That means even if we start this on instead of the day number 0, if we even start it on the second day, then also it will take 2 days and it will be completed on 4th day. After the 4th day, activity C will take 3 more days, so that is 7th day. But even if we start on time, this part B and D will complete only on the 9th day. So that means we could start these activities A and C on a later date than it was scheduled. So, but what is the latest that we can start this activity? That means it has to be started so that it is completed on the 9th day, which is the path completion time of this path B and D. Therefore, in this simple calculation, we can calculate simply that it may be started on the 4th day and it will be completed. Activity A will be completed on the 6th day. After that, it will take 3 more days and will complete it on the 9th day. And on 9th day itself, the other activities are also completed. So activity E will not be delayed because of delayed start in this part for activity A and C. Now latest finish time is simply the when it is started on the latest start time, and you just add to that the duration, and that will be the latest finish time for an activity. So earliest finish time is earliest start time plus duration, and latest finish time is latest start time plus duration. Now also one thing to remember is EFT of predecessor, or earliest finish time of predecessor, is the earliest start time of successor, and latest finish time of predecessor is the latest start time of the successor. Now here we can say that these two activities A and C are not very critical in the time calculation or calculation of total duration of the project, and therefore they are called the non-critical activities. But the activities B and D, they are basically governing the total duration of the project, because they cannot be delayed even by a single day, because that will affect the total duration. So these activities are called the critical activities, and the path B, D and E, B, D, E is called the critical path, while this path, that is A, C, E, is a non-critical path. So a critical path is the path of activities which governs the total duration of the project, and all the activities in that particular path are called the critical activities. And critical activities must be started and completed according to the schedule. That means they cannot be delayed even by a single day, and the maximum duration by which a non-critical activity may be delayed is called float or drag. So in this example, as we have seen, that it could be delayed by 4 days without affecting the total duration. So for this particular path ACE, or only for A and C, the drag or float is of 4 days. That means it can be delayed by a maximum of 4 days. If you delay it by 5 days, then this will be completed only after 10 days, and the entire project duration will be affected. So this is called either float or drag, and float is basically, you can calculate as latest start time minus earliest start time, and float or drag for critical activities obviously 0, because they cannot be delayed even by a single day. Now in the previous example, it was a very small and simple example, but for some complicated and large network of activities, we'll have to follow a certain procedure. So procedure for this kind of calculation of total duration is, it comprises of two activities. So one is called the forward pass. We'll now focus on the activity on arrow method firstly. So in forward pass, what we do is we try to find out the earliest start time of all the activities one by one, and therefore we also find out the earliest occurrence time of an event. Now the difference between earliest start time of an activity and earliest occurrence time of an event, it's actually the same thing. However, if you consider an activity, suppose A, then when it is started, suppose on the second day it is started, then on the 5th day it is completed. Suppose it is taking 3 days of duration. So this day 2 is the occurrence time of this particular node. Suppose this node is called I and this node is called J, and so this represents, the day 2 represents the starting time of A, but at the same time it represents occurrence of this node I. So this node I may represent beginning of activity A and also the ending of activity which was predecessor to A. It may be any other activity, B, C, or X, Y, something. So whatever was the predecessor activity, so its completion and the beginning of the next activity is represented by this node. So therefore, these two sentences actually mean the same thing but in different context. Now, so we'll carry out a process called the forward pass, and so the steps are, we'll start from the first node. That means we'll have to start from node 1. You can give numbers to these nodes, but if you don't feel the need, it can be completely skipped. So we'll start from the first node and we'll have to check all the arrows meeting at a single node. That means if we go to node 2, then there is only one arrow meeting at this node, so we don't have to worry. Now let's start from first node and we'll draw these kind of boxes, and on the first box we'll write the starting time or earliest starting time of this activity, or the earliest occurrence time of this particular node, that is node 1. And definitely because it is the first node in the whole project, so it will start from 0. Now after that, if we go to this node number 2, this represents completion of activity A, which will take 2 days, so we can write here 2. And for this particular node, it will take 0 plus 7 days, so we can write 7 here. So this 7th day represents completion of activity B. Similarly, here we can write 5 because C has taken 5 days from the beginning. After that, we'll go to node number 5. In node number 5, it represents, now here we can see there are 3 arrows meeting at node number 5. Now one of those arrows is a dummy activity, actually this one. So what does this mean is that this activity which starts from node 5, activity F, is dependent on activity D, activity E, and activity C. Now after completion of activity C, we are using this extra dummy activity to show the dependency of this activity F on both all of 3 D, E, and C. Okay, now when we go to this node 5, now node 5 represents completion of all these activities D, E, and C, and for that we'll have to look at the maximum of all the finish times of the activities meeting at the node. So the earliest that we can arrive at this node is when the longest activity chain or activity path is completed. So what are the paths? There are 3 paths: A, D, B, E, and C. There is no other activity after this because it's only a dummy activity. So out of these, which will take the longest? Only after the longest is completed, we can start the next activity. So therefore, we'll calculate now. This is 2 plus duration 4, that will be 6 days. Then along this path, 7 plus 4, that is 11 days, and along this path 5 plus 0, because this dummy activity is only an imaginary activity and its duration is 0, therefore 5 plus 0 is 5. So we have 3 total durations, and out of which the maximum must be entered here as the earliest occurrence time. That means on 11th day only, all these activities, all these previous activities can be said to be completed. However, a few of the activities are already completed, but we can say it is arrived only when all of them are completed, and therefore we have to take the maximum time, maximum of these durations. So we are writing here 11. After that, it is quite simple. There is only one activity left. So after 11 day, we will write 15 here, because that is 11 plus 4. So on 15 days, this whole project can be completed if we start everything on the earliest possible days. So all these first boxes in these nodes are representing the earliest occurrence times of those nodes. Now we have left some of the boxes empty, and that will be filled using a different process, which is called the backward pass method. Here the last one is 15. Now in backward pass method, we start from the last node, and it is done to calculate the latest start time of different activities, or it's the same meaning, the latest occurrence times of different events, which means the different nodes. So we'll start from the last nodes and we'll calculate backwards. While we do that, what we are going to do is we'll start here and we'll write the same number 15 at the last node, because we are expecting to find the latest start times or latest occurrence times of all these events when the total activity duration or the total project duration is not affected. That means even if we start some of the activities later than they were scheduled, the total duration, which is represented by this last node, should not change. So they are both 15 and 15. Now coming back, here again we'll check all the arrows emerging from a single node. So in the previous method, we checked all the arrows meeting at a node, but in this case we'll check the arrows emerging out of a node. So in this node there is only one arrow, so we don't have to worry, and we can simply write 15 minus 4, that is 11. So that means the latest that activity F can be started is 11th day, because that is the last activity. After that, if we consider the different activities here, activity D can be started at 11 minus 4, that is the 7th day. So even if we wait for 7 days, that means we wait for 5 more days and don't start on the 2nd day itself, but relax for 5 days and start on the 7th days, then also we'll be completing this activity on the 11th day. So the total activity duration, total project duration will not be affected. After that, if we go to this path, then again 11 minus 4 is 7. So we'll have to start it on 7th, and the earliest we could start was also on the 7th day. Now for this path, it will have to complete on 11th day, but the duration of this activity, the dummy activity, is 0. So 11 minus 0 is 11. Now what does it mean? Is that this activity 5 can be completed on the 11th day itself without affecting the total duration, while this activity must be completed on the 7th day, and this activity again can be delayed by 5 days and can be completed on the 7th day. So up to these nodes we have completed. Then we'll come to the latest node, the first node. So here we'll have to check the minimum of all the starting times of the activities emerging from that node is the latest occurrence time for that node or event. Now what does it mean? If we take 7 minus 2, that will be 5. That means this activity A could be started on the 5th day also. Then for this part, 7, that is the completion time, minus the duration will give us 0. That means this activity B must be started on day 0 itself. And for this activity, 11 minus 5, that is 6. So it can be started on the 6th day also without affecting the total duration. So out of all these times, the smallest or the minimum should be taken as the latest occurrence time of this event, which is represented by the first node, node 1. So this is how we find out the different occurrence times. So after this is completed, now we can have a clearer picture where we can say that activity A can be started on day 0, and in that case it will be completed on day 2, but it can be also completed on day 7th. And activity B can be started on day 2 at the earliest, but the latest it can also be started on day 7, so that it gets completed on day 11 without affecting the whole time period, whole project duration. Then after that, if we look at this part, then we'll see that activity B can be started on day 0 and has to be started on day 0, and it will be completed on day 7th. Then after that, activity E will start on day 7th and will be completed on day 11th. And along this part we can say that activity C can start on day 0 and complete it on day 5, but it can also be completed on day 11, and therefore it can be started on the 6th day, although that day number 6 is not mentioned in the whole diagram, but you can simply calculate it. Now out of all this, we can say that along the path B, E, F, these boxes have the same number on left and right chambers. So it has 0 0, this is 7 7, 11 11 and 15 15, while on this it has 2 7, that means both the times are different. Here also it is 5 11, that means both the times are different. That means the latest time and the earliest times of occurrence along this path BCE are same. Now, what does it mean? It means that the latest time is the same as the earliest time. That means it cannot be actually delayed. While on the other paths, the latest time is different than the earliest time, and therefore it can be delayed without affecting the total duration. And the path along which all these values are same, that means earliest time and latest time are the same, that path is called the critical path. And the activities are called the critical activities. So let's do a fresh example here. and this will be starting on activity on arrow method. So the activity can be drawn like this. It's a very simple activity network. So these are the durations. If you write these durations here along with the activity name, so we'll draw these kind of boxes here and carry out forward and backward pass processes. So the first box represents earliest time and the second box represents the latest time. So we start at day 0, then we go to this node, and this node will be giving us 0 plus 2, that is 2. Then in this node it will give us 0 plus 4, that is 4. When we go to this node, then there are 2 arrows meeting at this node. That means we'll have to consider the maximum time coming from these 2 arrows. So if we consider this arrow, then 2 plus 3 is 5. If we consider this arrow, then it will be 4 plus 5 equal to 9. So the latest of, or the largest maximum is 9, so we'll have to write 9 here. Then in the last node there is only 1 arrow, so we don't have to worry here. 9 plus 4 is 13. Then when we carry out the backward pass, we'll start from the last node and we'll write the same number here, 13. Then we'll come back to this node, and here 13 minus 4 is again 9. It's the same number. After that we'll go back here. This is 9 minus 5, that is 4, and this is 9 minus 3, that is 6. Now you can already guess what will be the critical path. This is going to be this one, because here these numbers and these numbers are different. Here these numbers are same, and here the numbers are different. And after that, when we come back to the last node, the first node, then we'll have to look at both these arrows coming out of the node, and we'll have to take the minimum of them, and that will be given by 6 minus 2, that is 4, and 4 minus 4, that is 0, and the minimum is 0, therefore it is 0. So these are the durations and the times. These are the earliest times and these are the latest times, and clearly in this case this path is the critical path, that is B, D, E. Now let's try to do the same example in activity on nodes method. In activity of nodes method, the writing pattern is slightly different, where in the node itself we are going to write all these things. So this is earliest start time, earliest finish time, latest start time, and latest finish time. And here we'll write the total duration of that particular activity, and we can also write the float of this activity. In the previous example also, here we could write the float. That means here the float is 0, here also the float is 0. On this the float is 6 minus 2, that is 4. Again in this case, since the latest and earliest time is same, therefore float is 0, and here also float is 0. So only for activities A and C the float is 4 days. On the activity of nodes method, we can designate a place inside the box to write all these things. So let's carry on with the forward pass. In forward pass, in the start node, we don't have to write any durations. So on activity A, we'll start with 0 and its duration was 2 days, and therefore the earliest finish time, if we start on the earliest date, is 2 days. Then we'll go to activity C, which can be started after completion of activity A, and its own duration is 3 days. So this will be transferred to here, 2, and 2 plus 3 is 5 days when it will be completed. Now let's go to this activity, activity B, where B can also start on day 0 because it's not dependent on any other activities. Its own duration is 4 days, and therefore the finish time is also 0 plus 4, that is 4 days. After that, activity D can start only when B is completed. So the earliest start time of B will be the earliest finish time of the previous activity, that is 4 days. Its own duration is 5 days, and 4 plus 5 will be its earliest finish time. After that, we'll go to this activity, activity E, where we'll have to look at its earliest start time. That means we'll have to take the maximum of the finish times of the previous activities. So this activity can be finished on 5th day, while this activity can only be finished on the 9th day. That means this activity, which is dependent on both of them, can only be started after 9th day. That means when both of this and this are completed. Its own duration, according to the table, is 4 days, and therefore its completion will be on the 13th day. Now, so that is the forward pass is complete. Now we'll have to go back to the backward pass. So we'll start from the last activity. So in the last activity, here we'll have to write the latest finish time, or that means since we are not considering any total delay in the whole project duration, so that time will be the same as 13. After that, the latest starting time will be the finish time minus the duration, so that is again 9. And for this activity, we can write the latest finish time will be 9 days. That means this value is simply transferred here, and latest start time is latest finish time minus the duration, which is 9 minus 3, that is 6 days. Then if we go to this activity, here again this figure will be simply transferred here, that is the latest start time of the next activity will be the latest finish time of the previous activity, and in this case 9 minus the duration, which is 5, will give us 4. And if we go back to this activity, here also we can simply transfer this to here, 6, and 6 minus 2 is 4. And in this activity, we'll have to write this 4 here, and 4 minus 4 will give us 0. And in these activities we can also write the float, because this chamber is reserved for the float. Now what is float? It is latest start time minus earliest start time. That means the amount, the duration by which it can be delayed is the same as latest finish time minus latest start time, sorry, earliest finish time. So here if you want to write it, it is either 13 minus 13 or 9 minus 9, that's the same thing, so that is 0 here. In this case 9 minus 9 is again 0, or 4 minus 4, which is the same thing, and here also 4 minus 4 or 0 minus 0, which will give us only 0. On the other part, on this part, 5 minus 9 gives us 4, the same is given by this also. So this is latest finish time minus earliest finish time, it gives us 4 days, and if we use this formula, latest start time minus latest earliest start time, that should also give us 4 days. Similarly, in this activity also, latest finish time minus earliest finish time gives us 4, or latest start time minus earliest start time will give us again same number 4. Now in a particular path, the float of all the activities will be actually equal. That means all these activities can be only delayed by 4 days, and if you delay this activity by 4 days, that means this activity can no longer be delayed, it has to start on time. So try to remember that part. So this is how we deal with this forward and backward pass in activity on nodes method. So we'll do another example, this one. I'll keep this for a different video because this has already become 42 minutes long. So thank you.